Nowhere in number 20, right, does it ask us to write a recursive formula. It does say, as we are looking at the problem, that we need to, if we are looking at that, it does say that we are going to use that information. So when you had 3 was at 52, right, and 5 was at 63, what did you find for the slope? Because we do have to do that. 11 over 2. Which 11 over 2 is?
5.5.
So you can write it as 5.5. And then you might go to your point slope form, y equals 5.5. Which point should we use? The first one or the second? The first. So x minus 3 plus 52. And what we said is if we were going to write that recursive formula, we might want to rewrite it in slope-intercept form. Or at this point, another thing you could have done was you could have said, okay, what is my x? 1, right? If you wanted to write a recursive formula, then you would have had a to the 1 equals, because that would have been 1 when you substitute 1. But this one just says, what's the height? What's the height of the height? So at this point in this equation right here, you can simply take x equals 9. And if you distributed that out, that's fine. But you wouldn't have to. You can just go y equals 5.5 times 9 minus 3, which is 6, plus 52. And you would have had 5.5 times 6 plus 52 to get that answer, which came out to be 85. So that's where that 85 came from. Are there questions on any other ones of describing it, generating your terms, looking at anything else? So that's, 20, you do have to do that on the test where you're going to have to go from 2 points to writing the different formulas, but this one, they didn't really ask us to do this recursive, this a to the 1 and a to the n. If you did, great practice. You want me to look at yours? I'll let you know if you're on or not. So, for arithmetic sequence, I can translate recursive and explicit form, so I got to be able to go between the two is what we're looking at. And I can convert a sequence into a linear function. So that linear function, a lot of times when we're thinking linear function, we might be thinking, an equation for a line, like slope, intercept. Or we might be thinking point, slope form. Usually, explicit and recursive, we're not thinking standard. It just isn't set up for a standard form. Okay? So an explicit formula is simply a function rule that relates each term in the sequence to a term number. Recursive is the one that always relates it to the first term and a common difference. And our goal today is we're going to look at these two forms, and you should be able to see how nice it is to convert between the two once we start going. So, as we are looking, it says a linear equation, y equals 4x minus 5. First off, if you were looking at that equation, what would you tell me is my y-intercept? Y-intercept is negative 5. And the slope, my rate of change is 4. Okay? So making sure we're understanding that as we look at it, so that now as we look at our equation, it says if we're going to rewrite this in sequence notation. So in sequence notation, the only thing that's different is that you're going to have a to the n, and I'm going to show theirs because it's neater writing than if I sometimes write. So it looks a to the n equals 4n minus 5. If you have it in slope-intercept, write it in sequence notation, pretty much we're looking at that being our, if we are looking at it, we can write it just like that. Okay? There's sometimes where you're going to see an n minus 1. Okay? So sometimes in the formula, you might see it written in the form of a to the n equals 4, and it might have n minus 1. And if it had n minus 1, then I can't use -5, right? I have to go back to, I have to add 4 on to -5, which is -1, right? So if I was going to put, right, -1, does that make sense? So if I use 1 in here, right, I'm going to end up with that. So when we look at this, it says all linear functions can be written as an arithmetic sequence. They all would have a domain of natural numbers. So when we graph it, remember, no fractions, no decimals, it's a discrete graph. Explicit formulas can be written in slope-intercept or point-slope form, just like any other of our linear functions. So if we take this explicit formula right up here, and we wanted to write it as recursive, what would our recursive formula be? If we plugged in our first term, n equals 1, right? If n equals 1, a to the 1 would be -1, which is what we have here, right? A to the n then is equal to a to the previous term, n minus 1, and we are adding 4 for n greater than 1. Now I know some of the ones in your book said n greater or equal to 2 are in your homework. I take it either way. You put n greater than 1 or n greater or equal to 2. So if you think back to this, the y-intercept here, 0, it would have been -5, right? If we would have plugged in 0 here, 0, -5. So that is our 0 term is at -5. But our first term was -1 if we are looking at that sequence. So it says, which of the following does not describe an arithmetic sequence? So remember, yesterday in your homework, there was one like this. There was only one choice, right? So there could be, and it says explain, but it does not. So arithmetic is when you add constant addition. First one, is it going to be arithmetic? No. Does that mean we're going to have 1 cubed? So no, and our reason would be we are cubing something, right? We've got to cube the number first, then add, so it's not going to be constant addition. And then in this case, actually, we're subtracting 6, but it's not going to be constant. If you put in 1, at 1 you would have had -5. If you put in 2, you're going to have 8 minus 6, you get 2. If you put in 3, 27 minus 6, there is no constant addition in that, right? How about this one? This could be a yes. Why? What's the constant addition? What is our constant number that we are adding? No, it's our constant addition. What's our slope? 4. Slope is 4. We are adding 4 on each time. So if you have an equation in slope-intercept form or point-slope form, or it's linear. Linear means x is to what power? 1. X is to the first. If you have x to the first and you have something times it, it is going to be arithmetic because you have a constant slope. Okay? So I want you to look at the next two, and if it helps you to determine, like to write the numbers out. So like in this one, if I would have plugged in 1 here, I would have had 11. And if I would have plugged in 2, I would have had 15, right? And if I would have plugged in 3, I would have, okay? I want you to talk to your shoulder partner and decide if you think the next C1. C to the n equals 2/3 n minus 5/3. Yes, no?
Yep.
Yes. Why?
N is to the first power.
What's that?
N is to the first.
N is to the first. What is our constant difference? So is this one arithmetic? Yes. What is our constant difference?
2/3.
2/3. Our constant difference, right, that we've been talking about, constant difference in this case is 2/3. So if I plugged in 1, right, if I plugged in 1, I would have had 2/3 minus 5/3. That would give me -2/3. I plug in 2. I'm going to have 4/3 minus 5/3. That's going to give me negative. So if I have 4/3 minus 5/3, that's going to give me a negative 1/3, right? Is that right? 2/3? No, the first one should be what? What's 2/3 minus 5/3?
Negative a third. Wait.
What's 2/3
2/3
minus 5/3? It is what?
1.
Negative 1. Then we have negative 1/3, right? If I would plug in 3, I'm going to have, if we are looking at that, 6/3, right? If I plug in 3 here. 6/3 minus 5/3 gives us 1/3. 1/3 plus 2/3 is going to give me, right, constant addition. It's going to give me positive. So even though you have fractions and decimals here, you are still adding a constant 2/3, that common difference. You have a slope. So the last one, is it going to be arithmetic?
Yeah.
Yes. We have a slope or a constant difference of -2. That is your constant difference. And if you are looking at that, also the variable n is to the first power. Anytime it's to the first power, whereas this one is to the third, anytime your variable n is to the first power, you will have it being linear and it will be a constant addition. Okay? All right. So it asks you to compare and contrast. On the tests, I was just looking through my tests that are making up and the review that you have to do. You're going to be asked to do some compare and contrast. So when we look at these two, I want you to try and think about how much could we say, how are they like, and how are they different? So similarities first. What do you think is similar in them? We look at the two equations up above. They have the same what?
Slope.
Same slope. Same what else? Y-intercept. Do they have the same first term?
No.
Yeah. So this one we didn't graph it. So when we are looking at what's the same and what's different in it, we would want to probably say, yes, we want to say first thing are similarities. Same slope of 4. That means the constant difference is 4. Slope of 4, constant difference. So in the sequence, it's our constant difference. In the linear equation, it's our slope. And both have a y-intercept of 5 if we are going to continue. What's different about them? The linear function is continuous, right? Anytime we graph a line, it's a continuous function. Whereas our sequence is going to be discrete. And it will only be positive whole numbers. So we aren't even going to graph the y-intercept down here of x equals 0, -5. We're not even graphing that because a sequence only goes from 1 to 2 to 3 to 4, and it doesn't have any fractions or decimals. Okay? And then that part at the bottom, it says, and you have that also in your notes, it says another name for arithmetic sequence is a linear sequence. This means there's constant addition, constant subtraction. And the key thing that you are looking at there is that slope and constant difference. Those kind of words are interchangeable when you think between arithmetic and linear. Okay? So, you'll be asked to do some problems like this. So that next one down, some of you are still writing this, so as you look at problem 3 in your notes, it says, step 1, find the common difference. This is your slope in the sequence that is 4, 11, 18, 25. Then it says pick any term from your sequence. So let's pick the first term, which is 4, and we'll have an ordered pair. And so then it's asking you to write using the point and the slope, write an equation. But instead of x, you're going to use n. What's the easiest form if you have a point and slope to use? Point slope. So we're going to start with that. Okay? So discrete versus continuous was the main difference. Okay? So, what was our slope as we look at this? M equals? What's happening from 4 to 11, 11 to 7? We're adding 7. So our slope is 7, right? So they say let's pick a point. 1, 4. So if we are looking at this equation, again, we don't want to have x like in a linear equation, right? So we are going to have, because it's a linear sequence, we want to write it as a to the n. A mostly because it's arithmetic. I don't care what letter you use. You can use T or M or whatever you'd like here, okay? Equals. Our common difference is 7 times, if we are looking at n minus 1, point slope form, right, plus 4. You are done. That is, you are done giving your explicit formula. Point slope. You do not even have to change it so that it's n. You don't have to distribute it and write it in slope-intercept form. You're done. It says you could also write this in slope-intercept form. If you were going to write it in slope-intercept form, because a lot of you on the last test, when I said write them in slope-intercept, you left a lot of your equations like this on that last quiz. So making sure, if we are asked to write it in slope-intercept form, right, you would have had 7n minus 7, so we would have had 7n. And if I have minus 7 plus 4, that's going to be minus 3. These two are the same equations, just that this is point slope and this is slope-intercept. Okay? I would recommend just stopping at point slope. There's no reason to change the explicit formula this way. Some of you will make some silly mistakes. We're going to leave it that way. All right. So we want to generalize as we are looking at this. So it says if you're given term number 1, how do you want to write your equation? We want to write it point slope. Okay. So when we look at this, if we are given an equation and you're given the term number 1, you definitely want to go point slope. Okay? Point slope if you're given term number 1. We do not want to have this with term 2 or term 3 or term 4 because we always want to have n minus 1 when we do this because we want to have this being our first term. Okay? So if you have the 7th term, you do need to find what your first term is. Okay? So the common difference, and parenthesis n minus 1 plus our first term. If you are given term 0, you are then going to go slope-intercept. So if you're given term 0, you want to think slope-intercept. Okay? So slope-intercept. Okay? So if we are looking at that, slope-intercept. So common difference, that's still our slope, right? Common difference is our slope. But now you have the 0 value. Okay? Everyone have that down? Okay. Give me a thumbs up when you have it down. 10. Each subsequent row adds 2 more seats, which means our common difference is 2. The last row has 64 seats. A to the n is 64. We just found out that this was 64. And the question says, how many rows are there? So what you're going to do is you're going to start with this explicit formula. Okay? We were given our first, so this is point slope form, correct? Right? This is our point slope form. Okay. We are going to put a to the n. What was a to the n? 64. It's just solving an equation. Equals our common difference was 2. Our n was, just keep it as n. That's what we're trying to find, right? That's our question mark. That's what we don't know down here. And then we're going to have plus 10 was our first one. You're going to distribute. Could you subtract 10 first?
Yeah.
Yes. Could you distribute first?
Yeah.
Yes. So there's a couple options of how you're going to solve it. What do you guys want to do? Distribute or subtract? Distribute. Some of you are going to do it, so whichever way you'd like to do it, you can do it that way. So I myself, if I'm looking at this, I'm probably going to subtract 10. I look at it and it's an easy one to subtract, and I get 54. I'm going to do my work over here. Is equal to 2 times n minus 1. And I then wouldn't still distribute, because 2 times this equals 54. I can see they're both divisible by 2. And 20, what's that? What was your question? Okay, so we're going to leave this as 27 equals n minus 1, right? And we are going to add 1. And we get 28. Oh, what if you would have done it with distributing, and you had 64 equals 2n minus 2 plus 10, and you would have had 64 equals 2n plus 8. You subtract 8. 2n is equal to 56. Still get 28. So does it matter? No. So just make sure you're checking. So solving the equation for the variable that you didn't know. There's 2 ways of solving it. So just making sure you're going back and applying your rules of solving equations that we did back in Unit 1. So we have this picture here, and then we have an equation. So the explicit formula for the following arithmetic sequence. First off, easiest way to do it is look at our what? Which formula? We're given the first term, right? Yes. This is our first term. So we need our common difference, our slope, right? Which is 10. A to the n is equal to 10 times
n minus 1
plus a negative 5. Could you just have minus 5 back here? You have to use the first, right? So remember, for point slope, you are using that first point. So a wading pool filled to the depth of 36 inches and drains out at a rate of 3 inches per hour. How much water is going to be in our bear's wading tank? They're spilling the water out. Okay? Do we know the first term?
Yeah.
The first one is 36. Do we know our common difference or our slope? There you go. Write the equation, please. You know the point, you know the common difference. Explicit formula is simply putting down what? Point slope. That's all you're doing. Some of you haven't written it yet for either one of those. We're going to fill both those in. Yes. You don't want to do it. You got to use the first term. It has to be the first. So good question. What if on that first one up here you did not use, you wanted to use the second term or the third term. You wanted to use 2 or the 5 or the 15. Explicit formula either has to be the 0 term or the first term. You cannot use the second, third, fourth, fifth, whichever one you like. It's either the 0 or the first. Okay? Has to be one of those two. You cannot use any other term. So you have to know either the first one. So if we were looking at that, right? Does that look right?
Yeah. That's in slope.
Slope intercept? Oh.
What if you know the common difference in the terms other than the 0 or 1 term? And can you still make a formula?
Say it one more time.
If you know the common difference in one of the terms besides the 0 or the 1 term, can you still make a formula?
You can make the formula, but then you got to go back to have it in explicit where it has to be either n minus 1 or this has to be an n. So the question is, could we have, because should we have had, so should this, is this our 0 term or is this our 1 term? 1. So if it's at this and it drains 3 inches per hour, did it start at 36 or was after it started draining? So 1 is at what? 33. So this is our 0, 1. This would be our equation y equals negative 3 times n minus 1 plus 33. This is going to be my 0 term. Okay? 0 term, 36. First one, 33. My fault I had the 1 up there with that to start with. All right. So you decide to start a fitness plan. You plan to run a half a mile the first day. That's 1/10 of a mile each day after. Each successive day. We want to write our explicit formula that you will run on n days. So when you read it, on the first day, day 1, how much did you run? You ran a half. So that's kind of like our 1/2. Because at 0 days, you haven't run anything, right? You haven't run anything yet. So you can decide which point you want to use. Do you want to use the 0, 0? Or do you want to use the 1/2? Please write your equation. Please write your equation. Abby, which form do you want to use? You want to use the n minus, do you want to use the 0, 0, or the 1/2? 1/2. So, y equals, how's it changing, Liz? Or a to the 1/10. I don't care if you use 1/10 or put 0.1, right? Do the same, right? Times, and then keep going. What am I going to have?
N minus 1.
Yep. Plus 0.5 or plus a half, right? So you could have had decimals for this. You could have had 0.1 and minus 1. Did anyone do it in slope-intercept form?
Oh, no.
You don't have to. We now want to change it to recursive. This is so nice if you use the n minus 1 to write it in recursive, because what is a to the 1?
The 1 is 1/2.
1/2, 0.5, right? Our second equation, a to the n, just like you did today. This is what you're going to be asked to do in your homework quiz. A to the n minus 1 previous, right? Plus 0.1 or n greater than 1. Okay? Talking about just our natural. Okay?